Today, I'm going to talk about the co-designing of software and hardware for RISC-V processors. Everybody knows CPU is a hardware, but CPU is not just a hardware. CPU needs to work with software. I call it hardware is the skeleton, while software is the soul. Today, I'm going to specifically talk about from the application perspective. There are three pillars for the RISC-V for application success. First is, we call it TikTok of software and hardware co-development. The second is the multi-extensions. The third is the advanced architecture. If we narrow down first into the co-development, we use the model as TikTok, while Intel doing the process and the CPU designs. Which means when we start with a new architecture in the hardware, we focus and do the innovations, and then keep the software as stable. And then we verify our new architecture. Then we do more things for the innovative software invention. This is the things we've been doing recently. Several years ago, we open sourced 4 CPU IPs to the world. It was listed in the GitHub and can be accessible for everybody in the world, including RTL codes. And then we go to release lots of patches for our tool chains and also optimization tools. After that, we switch back to the RISC-V core as well. So we provide to the community with the world's first 2 GHz SoCs for development for the universities and also the community. And then we switch back, as Chris mentioned, the OS porting. We start the Android porting and import lots of Linux into our RISC-V architectures. Then more IPs follows available to the public as a platform. We call it a template, so that our customers or communities can easily modify this design to their own designs. When they do the porting, when they do the design, we definitely need SDK for their own products, finally, for mass production. So we also provide the software for the designs for our customers. Speaking of the Android, several years ago, we started doing the initial work for the porting to the RISC-V. And that actually enables lots of terminal devices in IoT world. For example, cameras, keyboard, etc. We are very happy to work with Google to develop all these applications. Another famous OS, of course, is Linux. We have worked with lots of Linux vendors like Red Hat and Debian around the world, so that all these Linux commercial versions can be ported into our RISC-V machines. On the right-hand side, you can see this is just one example that we did. Starting with the XuanTie CPU, we built our SoC called TH1520. It's available. It's a SoC which running on Linux, and also we also provide the SDK for everybody. The second pillar is the extension. 8 years ago, when I first met Krista, he introduced me lots of things. One thing is the vector, matrix. All these extensions will be possible for RISC-V, so that customers have their full control on their own destinations. This is the picture probably all you're familiar with is the modularizations of the design. So every customer or companies can do the customization and scale their own RISC-V designs. The scalability is very important. That will actually defined by applications, what I will talk about more, how the application drive our own designs. DSA. DSA is the things nowadays becomes more available, and it's an inevitable trend in our design in this new era. In the center is the diagram that I showed last page. On the left-hand side, you can see we did lots of things from the software side, and the right-hand side is from the hardware. We have the extended ISAs can be specified using description languages so that our users can easily do their extensions using this description language. And the right-hand side, you see the hardware. There are lots of mesh among multi-cores and a shared crossbar design among the multi-cores as well. We have our own verification methodology that will enable the customers to do their own designs for their own application based on their specific architecture. The next exciting thing is the accelerator. Krista also mentioned RISC-V actually started as an accelerator design, and later on gradually moved into a CPU design. In the recent years, if you look at this picture, 2021, RISC-V has built the vector extensions, and 2022, during the pandemic, lots of companies like Meta, Esperanto, and TenstorRent, they have their own AI chips based on these extensions. And last year, we have two important interest task groups formed to work on the acceleration of the different applications. This year, lots of things are going on, including vector extension. All these things are helping us to build more parallel computing capabilities for RISC-V. This is just two examples that we have worked with the community. One is left side is matrix extension, right-hand side is vector engines. If you look at the left-hand side picture, you can see the speed up of the parallel computation using matrix and also vectors. Matrix can be about 6x faster improvement for the performance. And the right-hand side is a wide width vector engines to accelerate the transformer applications. The picture is a little bit different. The left-hand side is for performance. The right-hand side is for the time used. So at the right-hand side, the shorter bar, the better. You can see we have 17x improvement. So our computation extension, that's at the bottom. We use scalar engines, vector engines, and matrix engines. The last, not least, is the advanced architecture. We need to design more complex architectures for complex computations. These are the XuanTie series, C series just for computations. From left-hand side to the right, we have the very low power application processors to the processors which can be used for more complex computations. In between, we have matrix enhanced, max efficiency, and advanced AP, and also the parallel computing enhanced. In the near future, we will release a server-grade CPUs very soon. This is just the preview of the C930 that we will be releasing late this year. Its performance 15 per gigahertz, and you look at the main features, it's a 15-stage out-of-order superscalar pipeline, and there are lots of features you can read from the right, including the matrix extensions, and bottom you see the memory, control memory, improvement in real time, in the CPUs, in the interrupt, and also in the I/O hypervisor pass-through as well. Among all these three pillars, safety is very important. Reliability and a real runtime is important to our applications. XuanTie got the world first function compliances certification for the RISC-V itself. And we use all these safety and the real runtime applications in our own products. Say, for example, through the mobile and the wearable payment for Alipay. For servers, distributed privacy computing is very important. Don't worry about the naming XDM, ME, these are the names we coined. But essentially, these features we implemented to enhance our secure virtual machines, to ensure the security and safety of the transactions of financials, which is especially important. And one thing, say, for example, on the right-hand side is you can see the dynamic memory access is very important. So these are the detailed technologies we would like to implement in our own designs. For the real-time and reliability machines, we have R910, R908, and in the future we will have more these real-time machines as well. They will be applied to SSD controllers, switches, and 5G, etc. More specifically, we just released R908 last month. This machine is targeted for the high-end industrial applications, for example, storage, communication, computations. And on the right-hand side, you can see the diagram pretty much the same as you can see from the previous slides, but it's high reliability and also real-time OS support. It's including vector machines, vector computing engines as well. We are a system company, so we believe in the applications is very important to us. We design from the applications and use the driving strengths of applications to drive our designs, IPs, and SoCs. These SoCs can be used in high-performance computing, parallel computing, for the industrials and IoT applications as well. I'm a strong believer of Dave Patterson's vision. RISC-V will be the only computing platform in the future. Together with the community, work together openly and collectively, we will be able to design the best products for the world to enrich everybody's life on this planet. Thank you.